Okay, so this episode is called SDR and Signal Intelligence. Let's get straight into it. We're going to grab the tools out the boot that we're going to be using for today. But this is the big dog right here. If you want to know what this one's called, we'll tell you at the end of the episode, but you want to keep watching for this one right here. This device here is the RTL SDR, and in my opinion, it's one of the most cost-effective and beginner-friendly software-defined radios. Now, the reason I say that is because one, you can't transmit signals, which means you won't accidentally jam or create any interference with the devices around you. And two, the price of it is so cheap, you can get it for about 20 to 30 pounds, depending on where you look. Cheaper if you go on AliExpress. Now, it is limited. It receives a maximum frequency of, I believe, 1.5 gigahertz, which means there's no Bluetooth, no Wi-Fi, no Zigbee analysis. I've got a ESP32 powered drone here, which works by receiving Wi-Fi signals. We won't be able to analyze those signals using this RTL SDR. However, we can receive signals coming from LoRa devices, which works on 868 megahertz, as well as an abundance of key fobs coming from cars in the UK, which, as we know, work on 433 megahertz. It's originally based off a TV tuner chip, and there is a big community behind this device, so you'll often find the answers that you're looking for online. Someone's probably had the same problem that you've got when you're utilizing it. You can go online and you'll find a solution to that problem pretty fast, in my opinion, just because the amount of people that use these and the documentation of it makes it incredibly useful, which isn't the case with all software-defined radios. It's the case with a lot of them, but not the case with all of them. There's some software-defined radios that I've utilized and the learning curve has been vicious, simply because there's not much documentation or videos or help out there. So a lot of the things I've had to actually learn by myself, which can be a frustrating process. So with the RTL SDR, that's not the experience. There's an abundance of documentation and people with experience out there that can help you with these. So if you're a beginner, the RTL SDR is definitely one of the software-defined radios that you need to start with. Now, this device right here, although it may just look like, to some, if you're not clued up with electronic things, this may just look like a dead electronic board, but let me assure you it is not that. This software-defined radio is probably the one that I've utilized the most. Now, unlike the RTL SDR, it does transmit, and this is where firmware starts to really matter. It has a maximum frequency range of 6 gigahertz. So with drones, we can pick up Bluetooth. Literally, most devices that we come across in our day-to-day life, we can actually pick up, intercept, and manipulate with this HackRF. Now, these devices here are called PortaPacks, and I'll do a nice spin so you can see. What these actually do is turn the HackRF into a different beast, into a portable beast. Now, usually, by itself, you have to connect the HackRF via USB to a laptop like we've got in the back. With this PortaPack, you can actually pull it on top, or use this one, and we should just be able to push it all together. We'd have a battery in between the PortaPack and the HackRF, which will turn this into a fully portable device. As we can see, we've now got up, down, left, right, and center buttons, as well as a decoder that we can use to kind of flick between frequencies. So as you can see, the HackRF is capable of working by itself or working as part of a HackRF PortaPack combination. As you'll see later, the Mayhem firmware makes the user experience a million times better because we can perform things like bug sweeps all within one click, which brings us on to our next software-defined radio. So we've looked at the HackRF and we've also looked at the PortaPack H2 expansion. But this next device combines both of those into one called the PortaRF. Let's talk about it. So this is running the Mayhem firmware in the PortaRF, which we said was a combination of the HackRF with the PortaPack H2 in one solid device. Now, there's a plethora of things we can actually do within the Mayhem firmware, so let's get into it. Firstly, we can see receive, transmit, transceiver option. We've got recon, short for reconnaissance. We've got the capturing of signals, the replaying of signals. We can create remotes, looking glass, which we'll go into in a minute, utilities, games, settings, and the HackRF. Now, the HackRF mode is if we wanted to connect it to a laptop or a computer and maybe, say, use a program called SDR++, which we'll look at later on in this video. Now, let's start with the receive in the Mayhem firmware. Now, this is ADS-B for signals from airplanes. Let's just do a quick one on that. And as you can see, we're getting them instantly. Now let's go to, let's say, I don't know, this one down here. It's a Ryan airplane, as we can see right there. 2 engines. We've got the model, we've got the type, we've got the manufacturer, we've got the registration, as well as the ICAO. And as you can see, I'm in London right now, and this is the position of the Ryan airplane. Now that is ADS-B with Mayhem firmware. We've also got this one for boats. Now this is where we can receive Bluetooth signals that's being transmitted around us. Let's see POCSAG, which is pager signals, which I'm not really going to go into because sometimes this does give away some sensitive information. And this brings me to something that's really important. With software-defined radios, you must respect the radio spectrum, because not only are you receiving sometimes sensitive information, you can actually also transmit, and in doing so, you can interfere or jam devices which you didn't actually intend to. And radio police and Ofcom don't really care if you've jammed the device accidentally. As long as you've done it and it's caused a nuisance, you are liable for that crime. It is actually a crime to transmit on licensed bands without prior permission. So be cautious when you're using these kind of devices. That's something that's very important, and I can't stress that enough. Now, what the search app does is allow us to search within specific frequency bands, and if the device captures a frequency within the search range, which it has right here, as you can see, it's come up in green, it's going to do exactly that. Now, this is useful if we're searching for something like a hidden transmitter that we believe is in our room, or a GPS tracker that may be in our car, or if we just want to see a quick outline of what devices are transmitting within frequency ranges, you'd use the search. There's a similar app on this called, I believe, Recon or Scanner, which does exactly the same. Now, sub-gigahertz is for sub-gigahertz signals. That's signals lower than 1 gigahertz for those who didn't know. And as I'm not going to go through all of these, I'm just going to show them though. We've got electronic meters, FPV drone detection, satellites, the scanner app, which we spoke about, which is kind of like the search app, but it scans for certain signals, kind of like a radio frequency sweep, if you want to call it that. Now, with the Mayhem firmware, it also allows you to transmit. Now, as we said before, transmission of certain signals is illegal in the UK and in most countries, in fact. I'm not really sure if there's actually one country that actually allows you to transmit signals recklessly, because you can interfere with things like planes, emergency services. So I do believe in most countries that you come across, there will be some sort of rules and regulations of radio communications and the transmission and receiving of signals. But some signals that we can transmit are APRS, Bluetooth, as we said, and a few other ones that we won't go into. We've got Recon for reconnaissance. We can capture signals that's being transmitted. Right now we're on 2.4 gigahertz. That's the frequency for an abundance of drones, Wi-Fi, and Bluetooth signals. And one of my favorite is the actual looking glass. Now, looking glass is one of my favorite because it allows you to scan a wide range of frequencies. And because Mayhem firmware actually puts these into their own categories, as you can see, we've got the 433 megahertz band, aviation, aviation again, ADS-B, ACARS, FM broadcast. So here we go. Here's some that you guys are familiar with. Key fobs that work on 315 megahertz. Key fobs that work on 398 megahertz, 433 megahertz signals. Now, if you're from the UK, you'll probably know that UK car keys actually work on this signal right here, 433 megahertz. We've got LoRa signals, Bluetooth, and Wi-Fi here. As we said, just an abundance of signals that you can analyze. That is the Looking Glass app, and it's one of the best apps, in my opinion, on the Mayhem firmware for the HackRF. Now, if we go into utilities, we've got miscellaneous things, random password generator. Now, that is essentially the Mayhem firmware that works on most, if not all, HackRF devices. Now, this device right here is called the PortaRF. It's a combination of the PortaPack, which we've got right here, with the HackRF, which we've got inside of this +44 case. So yeah, this is the PortaRF, and it's a software-defined radio, just like this RTL SDR here. The final software-defined radio that we'll be looking at today is this bad boy right here. And this is a software-defined radio that is so unique, it actually deserves its own segment. What you're looking at here is a USRP B210, specifically open source SDR Labs rendition of one. What makes this version unique is they've taken the original design and made improvements on it, which gives it more processing headroom while staying fully compatible with the original. Now, this is not a hobbyist SDR. It's actually the kind of device you'd find in a research institution or within a telecommunications research lab doing some serious signal work, and that's often reflected in the price. Now, this is also the first device we've shown today that is full duplex, meaning it can transmit and receive at the same time. And that's significant because when you're conducting 4 or 5G base station research, the SDR needs to handle the uplink and downlink signals simultaneously. This is something that the HackRF cannot do, and something that would likely damage the RTL SDR if you even attempted to do it. It covers 70 megahertz all the way up to 6 gigahertz, and we'll be going further into what all that looks like in practice in the next episode. Okay, so what you're looking at now is me receiving the FM broadcast from a radio station using an RTL SDR, and as you can hear, we are picking it up. Now, this is the same way that a signal from your car's key fob, the signal from your transmission from a LoRa mesh-tastic device can also be analysed on a radio spectrum. No signal is invisible. Every signal will actually leave a footprint on the waterfall, just like these signals you can see here are leaving their footprint. So that concludes our episode on software-defined radios. However, if you'd like to see the utilization of these devices, you want to hit that like button and the subscribe button, because the next few videos are going to be doing exactly that, and you do not want to miss what we've got coming.